So in this part of the video, we'll continue our discussion of hypothesis testing, and we'll begin to talk about how a real hypothesis test actually works in a real data collection situation. So in in a real data collection situation or a research study, the null hypothesis is the possibility that a certain difference, relationship, or effect doesn't exist. In other words, nothing is happening. And the alternative hypothesis is the possibility that some difference, relationship, or effect does exist. And let me give just a few examples to help you get this point across. So imagine for a moment that someone wants to know, maybe a psychologist wants to know if there's a difference in self-esteem between people who don't use social media and people who do use social media. Well, in that person's data collection project, the null hypothesis is the possibility that there's no difference in self-esteem on average between people who use social media and people who don't use social media. The two averages or the two means are equal. The alternative hypothesis is a possibility that there is a difference in self-esteem between people who don't use social media and people who do use social media. So if if you think about it, in that situation, in that data collection project, there's either a difference in self-esteem or there's no difference in self-esteem. One or the other is true. It can't be both. And the goal of that hypothesis test would be to make a decision between those two competing possibilities and to hopefully uncover the truth. Um, Now let's imagine a person wants to know if if the temperature of a room has an effect on exam performance. So a person wants to know if being in a hot room will cause a person to do more poorly on an exam on average. Well, if a person is doing a study and collecting data on that topic, then and the person is doing a hypothesis test, then the person is trying to decide between two possibilities. The null hypothesis, which would say that temperature has no effect on exam performance, and the alternative, which would say that temperature does have an effect on exam performance. And when the person collects data and does the hypothesis test, the person will be trying to decide between those two competing possibilities. So in hypothesis test, you're you have a certain question in mind that you would like to answer, such as a question like, does the temperature of the room affect exam performance? You collect data, and then you run a hypothesis test on the data using a formula, and then after you run the formula, you make a decision between your null and your alternative, which are the two competing possibilities in your situation. So now let's move ahead. And next, I just want to give a few more scenarios, and in each scenario, um, um, show you what the null and the alternative are in that scenario. So here's our first example. This is actually one that we've talked about already. So imagine a person wants to know if working college students tend to be sleep deprived compared to other types of college students. Well, in that situation, H0, the null, is a possibility that there's no tendency for working college students to be sleep deprived. So H0 is saying that the average or mean sleep of working students is equal to the mean sleep of other types of college students. Um, H0 is saying that working college students are equal to non-working college students, at least on average. H1, the alternative, is saying that there is a tendency for working college students to be sleep deprived. So notice how H0 is basically saying that nothing is happening, that there's nothing interesting going on, and H1 is saying that there is something going on, that there is a tendency for working students to be sleep deprived. Here's another example. So now imagine if a person wants to know if there's a relationship between social media use and self-esteem in the college student population. Well, in that hypothesis test, H0 is saying that there's no relationship between social media use and self-esteem in the college student population. H0 is saying that people who use social media and people who don't are equal, at least on average. And H1 is saying that there is a relationship between social media use and self-esteem. In other words, people who use social media are different on average compared to people who don't use social media. And now let's talk about the two possible outcomes of a hypothesis test. So when you do a hypothesis test, you collect data, you run a hypothesis test formula on the data, and then the outcome of that formula actually leads you to one of two decisions. And those two decisions are reject the null hypothesis and retain the null hypothesis. If you end up rejecting the null hypothesis, you're deciding that the null hypothesis is false. You're throwing it out, basically. And if you retain the null hypothesis, you're deciding to give the null hypothesis the benefit of the doubt because there isn't enough evidence to reject it. So if you retain the null hypothesis, you're basically saying, my data isn't showing strong enough evidence for anything, so I'm just going to assume that nothing is going on other than just random chance. So like I said, when you do a hypothesis test, you calculate a statistic with a formula, and the statistic that you calculate leads you to one decision or the other. And let's go back to one of our scenarios and talk about what it would mean to reject or to retain the null hypothesis in that scenario. So imagine that I want to know if people who use social media tend to be different in self-esteem compared to non-social media users. Well, if I collect my data and I end up concluding that there is a difference in self-esteem between non-users and users, then I've rejected the null hypothesis. Because remember, in that scenario, the null hypothesis is a possibility that there's no difference in self-esteem, that users and non-users are equal on average. And if I've decided that I think that there is a difference in self-esteem, I've thrown out the null hypothesis. I've thrown out the possibility that there's nothing happening, and I've confidently decided that there is something happening. Now let's go back to that example on temperature and exam performance. Imagine I want to know if students who take an exam in a hot room tend to do more poorly, and I collect some data, I collect some exam scores, and I end up concluding that being in a hot room does cause people to do more poorly on average on an exam. If that's my conclusion, I've rejected the null hypothesis because I've rejected the possibility that nothing is happening, and I've decided that there is something happening, right? I've rejected the possibility that temperature has no effect, and I've confidently decided that it does have an effect. So that's rejecting the null hypothesis. Now, imagine I do my social media study, and I end up saying that my data isn't strongly supporting that there's a difference in self-esteem between users and non-users. So I'm just going to assume that there's no difference, at least for now. That would be retaining the null hypothesis because I've decided to just assume that there's no difference in self-esteem between the two populations simply because my data hasn't shown strong enough evidence that there is a difference. So I'm holding on to the null hypothesis and giving it the benefit of the doubt. Now imagine also that I'm running my temperature study and my data doesn't really show much strong evidence that temperature has an effect on exam scores. So I say, for now, I'm just going to assume that temperature has no effect, simply because my data didn't show much evidence that it has an effect. Well, I'm retaining my null hypothesis in that case. I'm holding on to the possibility that nothing is happening. So that's rejecting and retaining. So notice how the null hypothesis is the default possibility. It's what you start with. And then when you run the hypothesis test, you either reject the null hypothesis and decide that something is happening, or you hold on to the null hypothesis and say, well, at least for now, I'm assuming that nothing is happening because I don't have enough evidence to say that anything is happening. And before we move on, I wanted to give just a couple of everyday life examples, just to hopefully get the point across, get these concepts across as well as I can. So let's go back to the everyday life situation of car trouble. So imagine that you're in your car and you hear a noise from the engine. Well, if you if you decide that you're having car trouble, then well, remember in that situation, the null hypothesis is a possibility that the noise happened by chance, like a bump in the road, and the alternative is a possibility that you're having car trouble and it's not just chance. If you decide that confidently that you're having car trouble, you're rejecting the null hypothesis because you're rejecting the possibility that the noise happened simply by chance. If you decide that you're not worried because you only heard one noise and it could easily just have happened by chance, like because of a bump in the road, you've retained the null hypothesis because you're saying, well, you're thinking, I'm not convinced that anything unusual is happening, so I'm just going to assume that nothing is happening, at least for now. That would be retaining the null hypothesis in that situation. And before I wrap up this part of the video, I wanted to mention that hypothesis testing is a type of statistical inference. And if you might remember back at the beginning of the semester, we learned that statistical inference is when you reach a conclusion, it's when you take a sample and you reach a conclusion about a population without 100% certainty. It's when you collect data and you say, I'm confident that this is true about the population, but I'm not 100% sure. I might be wrong. So when you reach one of these, when you do a hypothesis test and you reach one of these decisions, the decision that you reach is an inference. You're not 100% sure that it's correct. So if you reject the null hypothesis, then that's just an inference because you might be wrong, the null might be true. And if you retain the null hypothesis, that's also just an inference because the null might be false. So no matter which way you go in a hypothesis test, you're only making an inference because you could be wrong after all. So a hypothesis test isn't a sure thing. It's just a way of making an inference based on data. And at this point, we've covered both estimation with confidence intervals and hypothesis testing. Those are actually the two major types of statistical inference, estimation and hypothesis testing. And in the next part of this video, we'll get into more detail about the possible wrong decisions in a hypothesis test.